The whole focus of this course has been on the value that data can provide to organizations in terms of guiding their decisions, making their operations more efficient, and many other positive effects. We've also talked about the importance of trying to get good quality data. Having said all of that, no data source is perfect, and so now let's talk about some of the things that can be issues with any type of data source, and then we'll talk about that with respect to specific types of data sources too. Something that can come up with any type of data source is that we need to bear in mind that the predictions that we make are going to be probabilistic in most cases rather than deterministic. What I mean by a deterministic prediction is that every single time that a certain set of conditions are present, we'll get the same outcome. For example, physicists dropping a ball in a vacuum know exactly what's going to happen with that ball, how long it's going to take to hit the ground. That's different than many of the things we do with humans, where we might know that it's more probable that when a certain set of circumstances are present, something is going to happen than when those circumstances are not present. But we don't know for sure every last time that's going to happen. So we might know that people with certain characteristics are more likely to vote for one political party than another party, but it doesn't mean that every single person with those characteristics is going to do that. Something else that's important to remember is that predictions outside the range of available data can be uncertain. What I mean by available data is the data that we use to generate the prediction. So for example, if we have a bunch of data from one country and we use it to make a prediction about what's going on in that country, that is generally fairly safe, assuming that we've taken a good sample and things like that. But if we try to extrapolate that result to another country, it's much more uncertain because we don't know that there won't be something different in that country that will make us have a different result than what we expected based on the data from the first country. The same is true for predictions about different types of people. For example, a lot of medical research used to just be done with young, healthy males, but over time people realized that women might respond differently to drugs and different kinds of medical treatments than men, and younger people might respond differently than older people, and sicker people might respond differently than healthier people. So we can't be sure that the result that we got with one set of people is going to apply to people with very different demographic or psychographic characteristics. We also can't be sure that results collected during one time period will hold in all other time periods. So for example, we might have been going along with a trend where when certain conditions are present, we do usually get a particular result, but then something can just change. Maybe a new competitor comes along, something changes with technology, something changes with society, and all of a sudden the future just looks very different than the past. The same relationships no longer hold. It's also important to recognize, regardless of what kind of data that we're working with, that our ability to get insights from that data is limited by a number of things. First and foremost is our ability to ask good questions. This is especially salient in this era of big data. I think that many organizations thought we have all of this data and now we're just going to get these insights as if by magic, but it's really limited by their ability to ask good questions of that data. The data won't give you the answers without you asking the right questions. It's also important to be able to get the necessary data. And again, in this era of big data, it might seem that that's going to be obvious and it's automatically going to be there. But in many cases, that's not true. Sometimes organizations don't have the data that they think they do. Sometimes it's harder to get the data they want than they think it's going to be. That might be for technical or logistical reasons. It can also sometimes be legal reasons. Maybe a privacy law or something like that prevents you from getting the data that you want. The ability to get insights from data is also limited by the ability to apply the right methods and use them correctly. So we went through the whole flowchart of matching the question we have to the type of data. If we don't do that process correctly and we're using the wrong type of data for our question, we might not get a good answer. Also, even if we're using the right technique and we've not applied it correctly, then we might be misled or just not get the right answer or the most helpful answer. It's also important to be able to interpret the results that we got within the context in which they were generated. Data tends to be really particular, and there's a lot of things that can make it seem to be telling us one thing when it's actually telling us something else. So if we don't understand something about the broader context, where the data came from, and if there were any flaws in how it was collected or anything like that, then we might think that we've reached a particular conclusion, but that conclusion might sort of be an illusion and just be a function of some underlying characteristics of the data or the context that we don't understand fully. Looking specifically now at actively collected data, some things that can go wrong there are that the people who don't participate are not representative of the people who do participate, or said the other way around, the people who participate are not representative of those who don't. A classic example of that is a survey, where we might send the survey to a representative sample, but not everybody returns it. And there's something about the people who do participate that's different than the people who don't. What often happens in that case is the people who do participate have the strongest opinions. They either love the organization doing the survey, or they really dislike it, or they've just got something that they want to get off their chest, or they're the people with more free time. But whatever it is, they're not necessarily a representative of those who don't participate. And so if we try to extrapolate the results from the people who did participate to the people who didn't, we might be getting an incorrect result. Sometimes, though, people participate, but they're unable to provide accurate information. This could be true for something like a behavior, where we're wanting to know how often people do a particular thing. Depending on the nature of that behavior, that can be something that people just really don't know the answer to. So for instance, if we ask, how often do you check the mail on your phone? If that's something that you do all the time, you just might not be able to provide a good answer to that, because it's just not something you're conscious of or keeping track of, and it's really difficult to give an accurate answer. There's other things in actively collected data where people are just unwilling to provide accurate information. This is especially true for socially undesirable behaviors like smoking or drinking or taking drugs or things like that. Moving on to passively collected data, there can be problems there too. For example, machines can go out, they can be poorly calibrated, and so on. And if any of those problems exist, then the numbers that we're getting from those machines will be incorrect. There can also be human error in setting up data collection systems. So maybe the machine is actually working, but it's not counting correctly because of how people set it up. This is especially important when we've got data being collected in multiple places. It could be that one person in one place just did something a little bit different than the people in the other places did. So we're getting a different result, but it's not a difference as a result of really what's happening in those places, but it's just a difference in how those machines have been set up. That also kind of gets to the next point, that there could just be inconsistencies in the way systems have been implemented. One area where this comes up a lot is with things like apps, where if one app has been implemented on one operating system and another on another operating system, those operating systems can have different defaults, or if they're set up by different people, those people might have made just slightly different choices. And those choices are having an impact on our data in ways that we don't necessarily understand if we're not cognizant of this. Finally, there can be misunderstandings about how particular data points have been built and defined and so on. Maybe the data point is just fine, but we don't completely understand what happened with that data point. For example, staying with apps, if we're trying to figure out how often people use something like the Mail app on their phone, we might have a criteria that says that that app has to be open for at least 3 seconds to count as a use, to take into account things like people just accidentally hitting it with their finger or it being bumped in their pocket or something like that. But if we don't understand that, then we might think that the real number is lower than it is. Or similarly, if it's the other way around, we think that the rule should be only 1 second rather than 3 seconds, we're going to misunderstand what the value that we're getting really means.